Alrighty, today we're factoring perfect cubes, the difference or sum of two cubes. First thing you need to think about is, what is a perfect cube? Well, integers that are cubed would mean, like, 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 8. 3 cubed, 3 times 3 times 3, 27. 4 cubed is 64, and 5 cubed, well, that's like 25 times 5. You all know that. That's like 5 quarters, right? 125. Now, the next thing would be cubed roots. What are the roots? Well, this is an inverse operation, as you'll start to see the pattern. 1 cubed means, what do you multiply 3 times to get 1? And here it is. We multiplied 1. What do we multiply 3 times to get 8? 2. So the cubed root of 8 is 2. The cubed root of 27, 3. The cubed root of 64, who knows? Oh, that would be 4, Miss Malone. And what about the cubed root of 125? That would be 5. So if I talk about the perfect cubes, I'm talking about these numbers. If I'm talking about the roots, I'm talking about these numbers. Okay, now the next thing is the sum and difference of two cubes has two formulas. Notice the similarities. You have a binomial, but the answer contains a binomial and a trinomial. And this is where SOAP comes in. SOAP's an acronym for the signs. Same sign as the problem. The opposite sign, always positive sign. That's what SOAP stands for. And yes, you do have to memorize it. It is a formula. You can't just figure out these things. Some nice genius person did, and we just get to learn how to use it. All right. So first, I look at this problem, this example, and I see the cube. That's a heads up. It's a binomial. And of course, 64, is that a perfect cube? Sure is. There it is. So recognizing that, I can now continue. What's the cube root of x cubed? Well, that's just x. And the cube root of 64. If you don't remember, here's your chart. Maybe you want to copy it down, take a picture of it. It's 4. Now I'm going to come up here and start filling in our answer. This is the basic format. SOAP would mean the same sign, opposite sign, always positive. All right, so what's the same sign as the problem? It's a plus sign. Opposite, of course, is subtraction, and always positive means always positive. So we fill that in. Now I'm going to fill in these spaces here. So this would be x and 4. Now, if you consider this the first and this the last, that'll help you to fill in these. In this case, the first one is always squared. So I take x and I square it. Then I multiply the first times the last. In this case, I multiply those two numbers in variables and I get 4x. And finally, the last is also squared. You can see that right up here in the formula. So what is 4 squared? 4 times 4 is 16. And that, ladies and gentlemen, is our solution. All right, let's do the same thing here. Now, first thing I do, I notice the third power, so I'm saying, okay, it's probably a cube. And then I notice the numbers. 27 and 125, yes, they are perfect cubes, so I can do this. Now, don't let this bother you that this is reversed, because yes, it's a little different, but we're all different, and that's okay. So we do the same exact process. Please don't switch them around. You cannot do that. This is subtraction. It's not commutative. So what's the cubed root of 27? According to our chart, that would be 3. And the cubed root of 125x cubed is 5x. I'm going to make my little template here and put in the 3, put in the 5x, but I didn't put in the sign. Well, what is it? According to SOAP, it's got to be the same as our original problem. Then the opposite, and then always positive. All right, what's the opposite? Well, plus sign. Now I can fill these in. This is my first number, this is my last. So what's the first squared? That would be 3 times 3 is 9. What's the first times the last? Do you have it? If you're thinking 15x, you're good. And what is the last one squared? Well, 5 times 5 is 25. And x times x is x squared. And that, folks, is your solution. Now, we're going to try this next one. Well, hopefully at this point, you're saying, well, you got a problem, Miss Malone, because those are not perfect cubes. There you go. They're not on that list. So, but I do notice the x cubed. So my first thing is to then look at would be the GCF, greatest common factor. Well, I know 2 has to go into 54. 54 is an even number. How many times is the question? So I'm going to divide them both by 2. When I take out the 2 here factor, I end up with 2x cubed. You can always check yourself by just distributing. 2 times x cubed is 2x cubed. I know this has got to be minus. How many times does 2 go into 54? And hopefully you're saying 27 times. Now, these are perfect cubes, and I can continue with the process. Now the 2, the greatest common factor, has to stay in front, and I'm keeping it there. And I will then make my little template. Let's use soap. Same sign is subtraction. The opposite sign is addition. And always positive is always plus sign. All right. Now, the first one, I'm sorry, not the first one there. The cubed root here is x. That's the first. And the cubed root of 27, hopefully you're getting the hang of this, is, what is it? Oh yes, it's 3. Very nice. And let's move on. What's the first one squared? Hopefully you're saying x squared. The first times the last. 3x. And finally the last one squared. Well, what's 3 squared? You know. Yes. You're saying 9. You're good. And that is the factorization of these cubes. All right, so there's your you try. You do it, I do it, and we compare our answers. So copy those down and pause your video, do your work, and we'll come back and compare our answers. Well, I hope you did good. Pause it, and now you're comparing. And there they are. How'd you do? A cubed, 125, the cubed root. I filled them in my little template. Did you remember the square? Do you remember your soap? Same, opposite, always positive. And here's the second one. Well, I hope that helps, folks, and that you got it. And, well, I guess all I can say is you have a great day, and I'll see you again next time.